right, welcome back to another episode of Coding with SpriteKit. Again, if you haven't tuned in for the previous projects, what we're doing in this series is we're using SpriteKit to code a clone of the Asteroids game. What I hope to do in this series and through coding this game is to learn SpriteKit, overall level up my coding skills, and make a fun game in the process. So I'm going to explain it again. The game is Asteroids, except I'm putting my own spin on it, and it's going to be called Asteroids. It's an ASS, Asteroids. And that's because instead of asteroids, there are going to be asses all over the screen that we shoot, and they're going to break into smaller asses. So that's my idea for the game. Hopefully it can be released on the App Store. Not too sure if it will be accepted because of the ass aspect of it, but we're going to try our best. So if you remember from last time, if you were here from last time, we had created the custom container node, and we had populated the custom container node with smaller sprite nodes or SpriteKit nodes, and we've for each of the sprite nodes inside of the container node, we've included a spaceship which represents the remaining lives for the player. So if I was going to point it out on the screen, these are the different elements. So we have the spaceship in the middle. That's our main spaceship that we use to fly around and shoot the asses. And then we have the scorekeeper up here in the top left hand corner, currently set at 99990, which is the highest score you can possibly achieve in the Asteroids game. Right below that, or right where it should be below it. So right below that is the life gallery, I'm calling it. And the life gallery holds the spare planes, aka lives, that you use in the game. So that's where we are as far as what we've accomplished. What we need to do now in this session is we need to somehow populate the container node with all of our lives. So in the actual game, you start with, I believe it's 3 lives at the very beginning. So you have the 1 life in the middle, which you start with, and then 2 additional bonus lives or ships in the upper left-hand corner. So we're having problems currently where we're getting an error whenever we try to include more than 1 sprite node. So if I can show you in the code, this is, where is it? Okay, this is where we are right now. This call is giving us trouble. So this call calls a function add node that lives inside custom container, and custom container is down here. This is the container node that I was talking about. It's a custom implementation because SpriteKit actually doesn't have its own collection view or table view or list. It doesn't have anything like that, so we had to make our custom container. So what this is doing, and I'll just go over quickly, it's creating an array of nodes, then it's executing this function called add node, and inside add node we're adding a child, which means we're adding the node to the parent node. So when we add this node, we're adding it to the parent node, which in this case is the custom container node, and then we're adding that node at the end of the existing array. Then we're calling this function right here arrange nodes, and arrange nodes is right below. Arrange nodes, what it does is basically sets the position. That's the main thing. So if you see here, we have node.position. We're tapping into the position property for each node, and we're setting its x and y coordinate. So here we have a special x coordinate. It's actually the offset. So the offset is actually incremented by 10, and this is, I'm pretty sure, 10 pixels. So as we go through this for loop, we'll be adding more nodes, and each time we add a node, it will be offset by 10 pixels, therefore giving it a little, like 10 pixels of space between each node. And as we add more and more, they should turn into a pseudo collection, like a pseudo collection that represents our lives. So that's what the custom container node wants to do. Basically, what we're having trouble with is this add node function. This add node function is called up here, just where we were. These two lines right here, of course, one is commented, but this line right here executes just perfectly fine. So you saw on the simulator here that we only have one life, one bonus life basically, and that corresponds to the one call we have here that's executing successfully. However, if I uncomment this line and try to call add node twice, you would expect that multiple lives, in this case 2, you would expect 2 lives to populate the container node. However, we don't get that result. We actually get an error. And I'll go through the error real quick. And by the way, if you haven't tuned in before, this is completely new to me. So you're learning as I'm learning, and we're going to go through this together as best as we can. And we'll be using tools like Stack Overflow, of course, GitHub, and ChatGPT, all the standards. So that's what we'll be doing in this video. So this is the error we're getting. Thread attempted to add an SK node. Here, let's copy it and paste it into something. Let's paste it into ChatGPT so we can read the whole thing. Okay, so we're pasting it here. Where is it? It's not showing up. One moment. Okay, so we're copying it. Please copy. And please paste for me right now. Alright, so this is the full error. It says thread 1 attempted to add an SK node which already has a parent. And then we have a few descriptions. We have sprite node name null, texture, SK texture, data, 6359, position 00, scale 100. So all this detail after the colon looks to be just the different properties of the SK node. I don't think we're really concerned about all these property of the nodes itself. We're concerned as to whether or not this entire node can be added to a parent. And what it looks like is that we're attempting to add a node which already has a parent. So that means we might be trying to add the same node multiple times. So that kind of makes sense if we look at our code again. So if we go back to game scene and observe the call that we're making up here, sprite node, we're actually calling this same function with the same sprite node. So this sprite node that's declared up here, we're inputting it twice, once in this call and then the subsequent call right after that. So it makes sense that the Xcode is complaining because we can't add the same node twice to the container, or we can't add the same node to a different parent. So we're going to need to call that add node method separately without the same node. So we'll see how to do that. So we're passing in a sprite node, we're calling add node, and then we have add node, we're calling arrange nodes. So let's see, what do we have here? So we're passing in a node, so it accepts this node here. When we call add node, it accepts this node. Then we're adding the child. Okay, that's fine. We're adding the child. And then it looks like we need to instantiate new nodes each time we do that. So we're adding a node, then we append the child node to the array. So we have one element in our array, as it is right now, since we only have one call. Then we call arranged nodes. The thing is, though, arranged node doesn't take a parameter, or it doesn't take an argument. So what is arranged node actually doing if it has zero input? So what is it doing here? So we are calling arrange nodes. We're setting the offset to 0. So then we'll say for node in child nodes. So this is us iterating through an array, which currently only has one member. It only has one element. It has that just one sprite node we're passing into this add node method. So this array just exactly is of size 1. Then we're adding that one node. So we have one loop, like one iteration. And we're adding that one node. But the thing is, we need to instantiate more nodes by just calling sprite node once. We're calling sprite node once. And then we need to add separate nodes. So it could be the case that we need to copy the node. That would work if the node is actually passed by value. So we can make a copy of it, and it doesn't think that it's the same object. So I'm just hoping that this is a value type versus a reference type. So what we can try is we'll take that node, add it to this array. So we'll add it to the array, and then we'll add it to the array, and then we need to be able to dynamically choose however many nodes we're adding. So what do we know about the game? We're adding only one life at a time to the gallery, so it only needs to execute one time, once at a time. So we should be able to just, instead of a loop, we should just be able to call it once. And as long as we get a new SK sprite node each time, that shouldn't be a problem. So we may not need the loop. We just maybe need to append, or we may be able to just add it to the container. So I'm just going to comment out arranged nodes here and see if we can customize this implementation to have it so that we're not using a loop, but instead we're just adding one node at a time. You know what? That's actually not going to work, because I believe at the beginning of the game you start with, like, we mentioned earlier that you start with multiple bonus lives. So let me look up the Asteroids game and just play through it and see how many lives we start out with. So I'm going to type Asteroids game, and here we go, freeasteroids.org. So I'm going to see if I can mute this sound, because it's pretty loud whenever we play it. So, okay, it's pretty loud. Okay, so we can see here that up in the left corner, we have 3 bonus lives. You see that? So we have 3 bonus lives. So which means at the initial call, we need to make it so that we're calling, we're actually looping 3 times, because the initial call needs to set a quantity of 3 in the array or the container. So that's what we need at the very beginning. So maybe we should be able to hard code this. May or may not. The reason I'm hesitant about hard coding just the number 3 as far as the number of iterations is because later, if we want to add another child node, we wouldn't be able to add just one. We would have to add 3 each time we call the function. So we do want to do it dynamically. An array does it pretty well. The thing is that this for loop is looping through an amount in the array equal to the number of nodes that we pass into it. So like I mentioned, at the beginning, we want a loop so we can set the initial 3. And then later on, we just want to add 1. So maybe this for loop is okay, and then we need to copy the node before it's called into, and then call the method 3 times. So maybe we need a for loop in the calls. So so right here, this is where we want to make our for loop, and then we want to pass by value. So what we may need to do is just, we'll say for at the beginning we may need to just add 3. So we'll say for, we'll say for 1 in 2, or we could say 4 is less than 3, and then we could attempt to instantiate a new node each time. So we could say, we can paste that there, and then we could say, we could just make a copy. Okay, we can make a copy. So we'll say let's new sprite node equal sprite node. So we'll do that, and then we'll call this method with new sprite node, and hopefully each time this is going to be called by value. This is going to be called by value, so we should be able to get the initial 3. So let's just set up the initial 3 just to get it working on the screen. So let's run the app, and if the nodes are passed by value, we should get a copy, and we should be able to get 3 spaceships in the gallery. Oh, okay. So we got a fatal error. So it looks like the sprite node is actually passed by reference. That's what it looks like. So it's a reference type, it looks like. So let's actually confirm that with ChatGPT. So I'm going to say our SK sprite nodes reference types or value types. And let's see what ChatGPT says. Okay, in Swift, SK sprite node is a reference type. So that's what I thought. I mean, that makes sense as far as why it's giving us the error. So let's read a little further. It says, in Swift, SK sprite node is a reference type. Reference types are instances that are shared among multiple parts of your program. When you pass a reference type to a function or assign it to a variable, you are working with a reference to the same instance in memory. If you modify the instance, those changes are reflected everywhere that references it. So this is a reference type. So that means we're going to need to copy this node in some other way. We need to instantiate the same information about the node, like its color, its size, and like all the details about the node. Uh, we need to copy all of that without. We need to copy all that somehow, because right now, whenever we assign a current sprite node to a new constant or a new variable, what we're doing is just setting a new reference, and that's not going to help it, because if we set a reference to the original, that means the new and the original are both pointing to the same parent, basically. So we need a way to generate more spaceships. So basically, we may need to instantiate all of this at once. So we may need to do this whole thing, all of this information up here, all these properties. So let's cut that and paste it into the for loop and see what it does. So we will erase this. We will set this to lowercase, and we will get rid of this as well. So, in essence, what we're doing with every loop is we're running through new declarations of every single piece of information we have, including the declaration of the sprite node. And when we declare the sprite node, when we declare the sprite node, we're actually calling the initializer of the sprite node class. So we're instantiating a brand new object here. And we know that because we have the parentheses here with a parameter, which means we're calling the initializer, which means it's a brand new object. When we're instantiating a brand new object with each iteration, the SpriteKit should recognize it as a totally new object. So with what we've done here, let's go ahead and just run the app. We'll see if we get 3 in the gallery. So the build succeeded. That's good. And there we go. We have 3 lives. Perfect. So we'll continue a little bit further because this isn't perfect. What's happening here is that the lives gallery is extending outwards towards the right, and that's because we're actually increasing the offset value by 10 instead of minus 10. So I'm going to change this to minus 10, and then it should be extending out to the left. And also, to make it more compact and look like the original game, I'm going to change the size of the sprite node to 20, and that should make it both closer to the original game, and it should allow us to have a size that doesn't interfere with the scorekeeper above. So let's save this and run this again, see how the size and the arrangement of the nodes is. Okay, so that's a little too small. They're a little jumbled together. Actually, the size is fine, but they're a little too jumbled together. So we want it to be negative. Okay, so I think this should be negative 60. No. Should be negative 30 because we have the sprite node, which is size 20 by 20, and then we want to offset by 20 minus 10, so 30 total. So let's run this again and see if we get a better looking gallery. Come on, baby. Okay, so that's actually not working. The offset is not working. let's go a little bit more extreme. Why don't we do 60 as far as the offset? And we'll see if that gives us a better result. So we're just going to try more extreme values, which may give us the result we want. Okay, so we're getting closer. So they're a little bit too far away, so maybe 60 was too extreme. But we actually know that the larger the negative value, or I should say smaller the negative value, or the more extreme the negative value, is that we get more space in between the nodes. So 60 was too much, 30 was too small. So we'll try just 45, see if that gives us a good spacing. So we'll run it again. And that looks much better. The only thing is that the container class seems to be a little bit off far to the right. So let's check the alignment between the scorekeeper and the gallery, because the X value for both of those nodes, by the way, nodes are basically just elements that are on the screen in SpriteKit. So we have this idea of multiple layers in SpriteKit. We have the very base level, which is the SK view, and the SK view presents what's called a scene, and within the scene we have nodes. So it goes view, scene, nodes, and nodes are all the things that you see, like all the elements. And in this case, we have this main spaceship as a node. We have the score label as a node. We have all the lives and the containers as nodes. So when I say nodes, that's what I'm referring to, just elements on the screen. So now we want to align the label node to the we want to align the label node to the life gallery, because it's kind of offset. What I want to do is right align these two so it's perfectly over to the right. So we'll check that they have matching X values is basically what we want to do. So let's go back into Xcode and let's see what the position of the container is itself. So we have custom container position X equals score label position X. So it looks like it's matching the X position. However, it might be matching the left-hand side position. So it might be the anchor point basically of each node, which is the point at which we orient the node on the origin. That anchor point might be, I think it's in the middle. So we're setting the middle of the container node to the middle of the label node, so they're actually center aligned instead of right aligned. So that's what it looks like here. So we can play around with this, I guess. But first thing I want to do is confirm with ChatGPT how to do it. Okay, so we'll say, how do I right align two nodes with the same new nodes that are oriented how do I align one node? How do I right align two nodes that are stacked on top of each other? So that the very rightmost edge of each node matches the other. Okay, so I hope I typed in an intelligible prompt to ChatGPT. It might understand what I mean, might not. But it's giving us an answer, so let's let it generate. Okay, so we are getting a long answer even with a code snippet included. So let's check out what it wrote. So ChatGPT says to align two nodes stacked on top of each other, you need to set their positions in a way that the right edges are aligned. You also need to consider the anchor points of the nodes to ensure that the alignment is based on the right edges. Okay, so we knew that. That was my speculation that we're not correctly using the anchor points. So let's go a little bit further, and ChatGPT is giving us a code snippet. So it looks like we have node 1 anchor point CG point x1. So the anchor point is 1, which is the very rightmost edge, because it's the very rightmost edge. So this is 1 and this is 0. Normally the anchor point is 0.5, which is in the middle. When we go from 0 to 1, we go further and further to the right until we reach 1 itself, and that's the very most that's the rightmost edge. So in this example, we're setting the x coordinate, we're setting the x value to 1, which is the very rightmost edge, and then here we're setting the size and height, and I'm guessing that the second node's anchor point is also 1, and we're right. So the x value of the first node and the x value for the anchor point of both the first and second nodes are at the very rightmost edge of the node. So then when we set the position will be the position will consider the rightmost edge as its anchor point, and will basically render the node according to the rightmost edge. So that's what we're doing here. So that's pretty simple. We just need to set the anchor point of the score label and then also the container. So where are we? So what we're going to do is we'll say, excuse me, I'm tired. Custom container dot anchor point custom container. Do we not have an anchor point because this is a do we not have an anchor point because this is an SK node? Let's examine this a little further. So custom container, we'll just put a dot and then we'll go through the properties here. I'd be surprised if this doesn't have an anchor point built into SK node, because it would be really useful to align not only Sprite nodes but SK nodes as well. By the way, SK nodes are like a superclass of SK Sprite nodes. So SK Sprite nodes inherit all the properties and functions of SK node. So we have a lot that is the same between the two. And I would expect the anchor point is one of them, but it doesn't look like it does have an anchor point. So if we don't have that, we have to ask ChatGPT. I don't see a way around that. So we'll say the node that one of the nodes. We'll say one of the nodes that I'm trying to align is an SK node, not an SK sprite node. The SK node does not seem to have an anchor point. Anchor point. The SK node does not seem to have an anchor point property. And if you hear some beeping, I'm sorry. I think that's my neighbor's security system going off. So I hope they're okay. So we'll say one of the nodes that I'm trying to align is an SK node, not an SK sprite node. The SK node does not seem to have an anchor point property. How do I write a line in this case? How do I write a line if this is true? We'll say that. So hopefully that's an intelligible prompt for ChatGPT. I hope that's not the fire alarm, honestly. I wonder what that sound is. Yeah, I'm sorry. I'm sorry. I may need to cut this video short. Actually, I don't know how to edit videos just yet or do it well. So I'm just gonna check. I'll be right back. I'm so sorry. Okay, that was the weirdest thing that happened to me in a long time. And it's not that weird, so I guess everything's fine. The alarm stopped. So I apologize. I am back. So let's continue here. So if you're working with an SK node instead of an SK sprite node and want to align them, you can still achieve the desired alignment by manipulating their positions. Unlike SK sprite node, SK node does not have an explicit anchor point property, but you can use the position property to achieve similar effects. Okay, so let's see what they're doing here. So we have an SK node up here. We have a shape node, and we are we are adding the shape node as a child to the SK node. We have another SK node, and it looks like they're doing the same thing. In this case, we have a blue version in the second one versus a red version in the first one. So it looks like what they're doing is they have an X offset that's set to 20, and then a Y position that's set to the height divided by 2. And then we have a right aligned X equals size dot width. Okay, so let's work that out. So we have the X offset by 2, or 20. We have the X offset by 20. Then we have the Y position, and that equals size. So it seems weird that we just have this size property that's basically coming out of nowhere. We're not using the dot property, but this size property is a part of the SK scene, and that's, you know, that's a little bit frustrating that they don't explain that. That ChatGPT doesn't explain that, and that's one thing that kind of frustrates me about Swift, is that a lot of the functionality is so abstracted away that if you want to look under the scenes, like under the hood, and understand where these properties and methods come from, that you don't really know where they come from, and you have to go through the chain of inheritance to find out where they come from. So in previous videos, I did do some research on where that comes from, and the size property is part of SK Scene, or one of the superclasses of SK Scene. But the fact that we're inside an SK Scene means we could just say size, and that's automatically included in SK Scene. And then we could type into the height property of size. So what we're doing here in this line of code, we say let y position equals size, which is the size of the scene, and we're taking the height divided by 2. So basically we're taking the height of the scene, and then we're dividing by 2. So that should be in the middle, which technically does not work in our case because excuse me, it technically does not work in our case, and the reason it doesn't work is because our app that we're developing right now has an origin that's smack dab in the middle of the screen. So 0, 0 on the coordinate plane is right in the middle of the screen, and you know, you might be familiar with that from mathematics, but ChatGPT assumes that SpriteKit is using the standard graphic design coordinate plane with the origin 0, 0 in the bottom left hand corner of the screen. That's why it's thinking if we take the height divided by 2, it's going to land in the middle. It's going to give us a y position in the middle. But really we can't do that because if our origin's in the middle, we take the height and divide it by 2, we're actually giving it a positive value in comparison to the origin in the middle, and then the positive value compared to the origin in the middle is just going to put it on the top half of the screen, because it's going so much it's going, you know, whatever positive value upwards on top of the origin. So it's basically pushing it off the top of the screen or putting it near the top of the screen. So I just wanted to mention that detail, that this this computation of the position, this computation of the y position is not going to work. But let's move on to the next line of code. So we have let right aligned x equals size dot width minus offset. So we have the size width. Again, we're tapping into the size property of the scene, and then we have the width, and then we're going the offset of 20. So I'm not sure why we're doing that. We have offset. Okay, so we have size dot width minus plus the offset. So we have the offset here, and with the width, it's giving us this constant called right aligned. So when we have this value, we're plugging it into the x value in this CG point, and the x value corresponds to the horizontal alignment of the position of the node. So it's saying as long as we have the same value for the positions, um, then we're going to get a right alignment. Then we're going to get a right alignment. See, the thing is about this, it might be aligned to the center. It looks like it's aligned to the center. So I know the right alignment has to do with this offset. The right alignment has to do with the offset, but if we're moving both nodes to the right by the same offset, that won't necessarily right align the nodes, because the offset could correspond with the center of each of those nodes, and if the nodes are a different size, then they could just be aligned in the center because the offset is considering the center as the anchor point. And I know we don't have an anchor point explicitly, but if the if the analogous value or property of the SK node to a anchor point is in the center, then no matter how much we make the x coordinate the same, it could just be center aligning them. So let's ask ChatGPT the question. So it says, what if my SK nodes have different widths? So let's see what ChatGPT says. So it says, if your SK nodes have different widths, you can still right align them by adjusting their positions based on their individual widths. The idea is to calculate the position for each node so that the right edge is aligned. Okay, so it's basically giving us an answer where we have to hard code it, which is what we could have done from the very beginning, but I wanted to do it in a computed way so that it's ready for variable screen sizes. But it looks like the answer is we just need to hard code it onto the screen, which is not ideal. We may be able to compute a separate value to pass into the position property based on the relative screen size, or the relative screen size of the user's iPhone. Don't really know how that's going to look right now, but I'm just going to try to make it look good on an iPhone 15 Pro, because that's what we have right now. And I'm just going to try to make it look good in one instance, and then adjust however we need to when we support additional screen sizes. So let's just go ahead and hard code it. So it's giving us an example of hard coding. So it's saying it's saying node 1, create node width 50, color red. So we're adding that node to the SK scene. Then we're creating another node with a width of 70. So then we're creating an offset of 20. Then we're sending the Y position. Again, this Y position is not going to be applicable to our app. But then we have these other lines of code where we have the node 1 position. We have the size.width minus offset minus node 1 dot calculate accumulated frame dot width divided by 2 Y position. Okay, so I haven't seen this before. Don't know what calculate accumulated frame is. So before we use that, let's look at the rest of the answer to see what calculate accumulated frame is. So let's read further into the prompt. So we have ChatGPT is saying the create node function is used to create an SK node with a child SK shaped node of a specified width and color. The positions are calculated by taking into account the width of each node using calculated accumulated frame width. This approach dynamically adjusts the positions based on the actual width of each node, allowing you to right-align nodes with different widths. Adjust the widths and positions as needed for your specific scenario. Okay, I could understand that, I guess. It's kind of vague because they just tell us to use this thing without explaining what it is. So let's say explain what the calculate accumulated frame method does, where it is defined, and how it works. And I should get a big long answer, but we want to find out what we're doing and learn as much as we can about SpriteKit. That is our job with this series, so let's get the most out of it while we're doing it. So here's our answer. ChatGPT says the calculate accumulated frame method is part of the SK node class in SpriteKit. It returns the accumulated bounding rectangle that encompasses the entire node and its child nodes in the parent node coordinate system. The rectangle is calculated based on the node's position, size, and any transformations applied to it. Here's a breakdown of how it works. Definition: the calculate accumulated frame method is defined in the SK node class as a part of the SpriteKit framework. Usage: when you call calculate accumulated frame on an SK node instance, it returns a CD rectangle representing the bounding box that encloses the node and all of its child nodes. Okay, so we have, when we call that, it returns a value, and the return value is the CG rect type representing the bounding box. So it's basically just a rectangle that encompasses or delimits where the end of the all the elements are. So like the smallest rectangle that holds all of the child nodes. So let's read further. Coordinate system. The resulting rectangle is in the coordinate system of the parent node. If the node is a child of the scene, the coordinate system is that of the scene itself. Transformation consideration. The method takes into account any transformations applied to the node, such as scaling, rotation, and position adjustments. In this example, if you rotate the node, the calculated accumulated frame will reflect the rotating bounding box. This method is useful when you need to determine the overall size and position of a node and its children in the coordinate system of its parents. It's often used for positioning or sizing calculations when dealing with the hierarchical structures of nodes in SpriteKit. Okay, so that is interesting. We don't have any transformations right now, so if we do need to use some transformations in the future, we'll review this point. But I think I have a general understanding of what calculate accumulated frame size is, or calculate accumulated frame is. It just returns a CG rect. So we can actually just copy and paste this right now. Okay, so these few lines of code kind of mirrors what we have already as far as creating the nodes. So we know that we can declare nodes and put them onto the screen. So this line of code is fine. The Y position, we already know the Y position. That's not a problem in our app. And then the offset we have is 20. So let's take the offset of 20. Not exactly sure what the offset is doing though, to be honest. Why are we minusing the offset? Is the offset just so it stands off from the edge of the screen? Yeah, that's what I think it is. I think the offset is just to pull the it's just to pull the nodes from the edge of the screen, so we might not need that. So let's skip using the offset. So we'll take this line of code and modify it slightly and figure out where it needs to go. So we have, let's get rid of this. So we have to paste it here. So we have node 1. Okay, let's say okay, actually, let's not copy and paste just yet. We'll say, what if one node is an SK Sprite node and the other is an SK node? So let's see what ChatGPT says for this one, because this more closely represents that question, more closely represents what's happening in our app. So we have one Sprite node and we have one SK node. So let's see what it says. If you have one node that is an SK Sprite node and another that is a generic SK node, and you want to align the right edges, you'll need to handle them slightly differently due to the differences in their properties. Okay, that makes sense. Here's an example. So we have the scene. We have the declaration of the Sprite node. We have the Sprite node anchor point set to the right, and then we're adding the Sprite node to the scene. Then we have the generic SK node. Then we have the shape node of different width. So this is important. ChatGPT remembers that we're supposed to have different widths, so it's good that it's acknowledging the different widths in its answer. So we have a width of 70 for the SK node and a width of 50 for the SK Sprite node. And we're just creating them here, and then here we have the offset again. Again, I'm just speculating that the offset brings it off the edge of the screen. That's what I think. We could be wrong, but we'll try it both with the offset and without the offset, see if that does anything. So we have the X offset, and then we have the Y position, and same old story. The Y position is the height divided by 2, which is not going to work in our case. So the next line of code is it is a Sprite node dot position, CG point size dot width minus offset minus Sprite node calculate accumulated frame dot width divided by 2 y position, and then CG point size dot width offset minus 70. See, I don't get this. I don't get these coordinates. I don't get how they're coming up with these coordinates. Huh. Why do we have a hard-coded value of 70? Is that because the width of the... Is that because that's the offset? Let's ask it. let's say pretend that my coordinate system is such that the origin is origin 0 0 is in the very middle of the iPhone screen. Reproduce. Let's see what it does. So there's my prompt, chat GPT. Do your best. Didn't really give us anything different. Okay, let's examine this. It's basic geometry, so we should be fine. So we have this case we have sprite node dot position equals CG point, x is negative offset, minus sprite node calculate accumulated frame dot width divided by 2. So we have the width divided by 2 minus the offset. So what do we have here? We have a negative offset, which means we have negative 20, which means it's 20 to the left of the origin, which is in the middle. Then we have the sprite node, and we're tapping into the calculate accumulated frame method, which returns the CG rect. And then we're taking the width of that CG rect and divided by 2. So we have the negative offset minus half the value of CG rect. Half the value of CG rect. So why are we taking half the value of the CG rect? The x position is half the value of the CG rect. Okay, so we have the CG rect. We have half that. We have half that. And then basically we're moving that much to the left of the origin. So in essence, we have moved basically half over. Yeah, we've basically moved half the width over on the on the CG rect, which is kind of like being on the right side. Let's see what happens to generic node. So we have CG point offset plus 70 divided by 2. Why is this a positive value? Why is this a positive value? So we have x offset plus 70 divided by 2. We're just going to put it on the right side of the origin. Okay, so let's copy this. So we'll say y is one x value positive and the other x value negative. Okay, it's saying, okay, this is confusing what it's saying. It's saying the reason for the difference in signs for the x values is to achieve right alignment for both nodes. For the SK sprite node, the x position is calculated as negative offset minus sprite node dot calculate accumulated frame dot width divided by 2. This calculation ensures that the left edge of the SK sprite node is positioned to the left of the center of the screen, which results in a right aligned appearance. For the generic SK node, the x position is calculated as x plus 70 divided by 2. This calculation ensures that the left edge of the generic node is positioned to the right of the center of the screen, which also results in a right aligned appearance. The left position is positioned to the right of the center of the screen. Okay, I understand that. And then the left edge is positioned to the left of the center of the screen, which results in a right aligned appearance. That doesn't make any sense. I need the x values to be aligned. So I need the x values of each of the. I need the x values. I need the x values. So we'll say I need the SK node and the SK sprite node to be aligned by their right edges in relation to each other. In other words, I need the right edges of each of these to be the same x value. If you want the right edges of both the SK sprite node and generic SK node to align, you should calculate their positions based on the right edges. Here's the modified code. Okay, let's review this code. I'm spacing out a bit because it's so late, but let's review this code. Okay, so if you want to align the edges of both the SK sprite node and the generic SK node to align, you should calculate their positions based on the right edges. So we have the SK scene, we have a declaration of the sprite node, that's fine. We have a width of 50 in the sprite node. Then we have a declaration of the generic SK node, in which we have an SK shape node, excuse me, with a width of 70. And in both these instances, we're adding the child to the scene. So next is the important part. So we have let right edge x equals size dot width divided by 2. So we have the. Oh, one thing I should mention is that the anchor point of the sprite node is set to 1, which means it's set to the very right side. So we have the right edge equals size dot width divided by 2. So it thinks it's in the center, and then we are going minus 20. So we are. It still thinks we're on I still think it stinks. We're on a standard graphics coordinate plane. We'll say, remember, we are on a coordinate plane with an origin in the very center of the screen. Alright, come on, ChatGPT. Okay, so it regenerated the code. Okay. So here we have the declaration of the sprite node with the anchor point all the way to the right, and then the width of that sprite node is 50. Then we have the declaration of the SK node with the width of 70. We have the right edge equals 220. Then we have sprite node dot position equals CG point right edge, which is 20. Then y equals 0. Then we have the generic node dot position CG point dot negative right edge. So y are we minus 20? Y equals 60. Right edge is the x position that aligns the right edges of both nodes. Sprite node is positioned at right edge x. Okay, so sprite node is positioned at right edge x, and generic node is positioned at negative right edge x to ensure the right edges are aligned in the custom coordinate system where the origin is at the center. How could that be? I'm not understanding. How could a positive x value and a negative x value possibly be aligned on their right edges on a screen? If the x values are different, then they're not going to be right aligned. So let's say, explain how the right edges of each of these nodes are aligned with each other if one x value is negative and the other is positive. I apologize for the confusion in my responses. Let me clarify the explanation. In the custom coordinate system where the orange is in the center of the screen, for the SK sprite node, the anchor point is set to 1 and then 0.5, meaning the anchor point is on the right edge and center vertically. The position is set to CG point right edge x, where right edge x is positive. Alright, so right edge x is positive. This places the right edge of the SK sprite node at a positive x coordinate. For the generic SK node, the position is set to CG point negative right edge y60, where negative right edge is negative. This places the left edge of the generic SK node at a negative x coordinate. Okay, the key here is that the anchor point for the sprite node is on the right edge and the position is set so the right edge aligns with the positive x coordinate. For generic node, the position is set so that its left edge aligns with a negative x coordinate. The overall effect is that the right edges of both nodes are aligned along the x-axis, even though one x value is negative and the other is positive. If you visualize this on a coordinate plane with the origin at the center of the screen, you'll see that the right edges align as intended. So let's try to understand this a little better. So I understand what it's saying, but with the actual data, I'm having trouble visualizing this. So we have width of 50, and then a width of 70. So we'll say right edge 20. X is right edge 20, so that's the right edge of the node. Okay, so we're just gonna ask ChatGPT basically to do this. So we'll say, so score label. What do we want the score label size to be? So we'll set the size with score label. So we'll say score label dot size. I guess the score label size is variable. Okay, I think I might be able to do this without necessarily just copying and pasting from ChatGPT. Okay, so we'll say score label dot anchor point equals CG point X, so 1.0, and this is 0.5. Okay, so we have an anchor point to the right, and then the container needs to be negative. Do we need the SK shape node though? Do we need the SK shape node? I think we might need the SK shape node. So let's input the SK shape node as well. I'm just guessing that actually gives the SK node a strict size. So let's do this. Custom container. Add child shape node. Okay, hopefully we're not going too far off the rails. Okay, and I'm just going to give this a width of... What should I give this width? I'm just going to give it a width of 100. That seems more like what we need. And it looks like this right edge 20 is the difference between these two widths. The width here and the width here. So if we're going to make this 50 versus 100, the right edge would need to be 50. Okay, so let's do that. Let's do that. So, we'll comment this out. Okay, we actually do have a position for the... We already have a hard-coded position for the... Yeah, we already have a hard-coded position for the label node. So, why don't we just hard code the position of the custom container? Huh. So this is going to be 50. It's going to be y minus 10. No, this is going to be score label dot position dot y minus 10. Okay, this is a little confusing. So, this is a little confusing. So we have this. Let right edge x minus 20 sprite node position. Let right edge x equal 20. Then we have sprite node dot position. Right node. Okay, so maybe we don't hard code the position here. Maybe we don't hard code the position. Maybe we don't have the position hard coded. We'll take this and input it right here. Okay. Sorry I haven't been talking. So we have this. Okay, sorry for talking. So we have this label dot position CB point right edge node. Then we have generic node, but that's not going to be generic. It's going to be custom container, and then we're going to add do we need to add the custom container as a child? So we need to add child custom container. All right, so let's see what this does. Okay, it says build failed. Cannot find label in scope. So we have score label now. Okay, come on. Build succeeded. Let's go. What's this gonna do? Okay. Attempted to add an SK node which already has parent. So somehow we broke our code. Somehow we broke our code. We're adding custom container down here. Okay, so we don't need to add custom container as a child up here. Just eliminate this, and then hopefully that will clear up that error. So we should get. Okay, now we're getting this box, and it's not right aligned. It's not right aligned at all. So let's adjust. Let's remove this. Let's see what we get there. I don't want to hard code this. That's the thing I want to avoid. So let's make the y positive 100. And the y here positive 100. Actually, the y for the custom container should be about 80. Nah, let's say 90. I'll say 80. That should put one on top of the other. Let's run it. I know we're kind of hard coding at this point, but we might just have to give up on the alignment. Yeah, see, the right edge of the container is aligned with the left edge of the score label. So why don't we make this both positive? And that's the problem we were running into before. So really all that work from ChatGPT did not help at all whatsoever. So let's just set the position manually. We're going to go x minus 225, and we're going to go x minus 240, I guess. And see what we get there. See if we're aligned. Close. Let's move it 5 in. I think we should have done this a long time ago. Although it was a good idea to get them right aligned. But we are kind of just up to hard coding it. And that looks like it's pretty much right aligned. Is it right aligned? I'm going to take a piece of paper. I know you can't see this on the screen, but I'm going to take a piece of paper and see if this is right aligned. Oh, yeah. Oh, yeah. That's right aligned. Okay, so let's move up the Y position a little bit. So, actually, let's move the X position too. So, let's make this 240 and then make this 230. No, let's make this 235 and make this 245. And then let's make the Y 110 and then this 90. This is an ugly way to do it, and I don't want to hard code it, but ChatGPT is not helping me out right now. Let's move it even more in the corner. Why not? So we'll go minus 245, and then we'll go minus 255, and then we'll go 120, and then we'll go 100. Okay, so that's pretty much where we want it. So now our screen is looking good. We have the spaceship, we have the lives gallery, and then we have the scorekeeper. So that's what we wanted to do. So we did a good job today. And I am going to just commit and call it a night. So let's go ahead and commit. Commit. We're going to say fixed. We say right aligned lives gallery and score label. Fixed size of lives in gallery. Able to create starting lives. Okay, let us commit. Stage all commits. And let's push. Why not? What time is it? It's 12:24 a.m. Alright, so we've been coding for 2 hours and we got some good work done. If you've tuned in for all the episodes, just want to thank you. If this is your first one, I just want to thank you. If you've actually made it this far in this video, I'm very surprised, but thank you. We'll keep coding. I hope to do this every day, about a couple hours a night. So, if you like this video, come back next time and smash that, absolutely destroy, decimate, smash, murder that subscribe button, and leave me a like or a comment. Alright guys, peace.